Hi and a very good day. So in this video session, I will continue discuss about basic inferential statistic by using R. Okay, this is actually one of the chapter under our programming. Okay, so before we begin, the data that will be used in this example is telco data, right? So I hope that from this point, you already know how to read the data into R. Okay, so here I will divide this chapter into two topics, which are assumption of normality and hypothesis testing. Okay, where I choose one sample t-test for this topic, right? So this is actually most basic thing because as you know, there are actually a lot of more inferential statistics that can be performed by using R, and of course it is not limit to one sample t-test only, but luckily this one sample t-test is the one that only being in your uh, topic syllabus. Right, okay, so let's take a look at assumption of normality. Okay, the thing is why we need to look at the assumption of normality. Okay, the assumption of normality is actually divided into two, which are the data or the residual, the error itself, right? But for this discussion, I only limit the discussion into the assumption of the normality towards the data, right? So we want to take a look at generally what are the characteristic of our data. Okay, so depending on the characteristic, it is actually uh, will will affect on the selection of our statistical analysis. Alright, whether you use mean or median. Okay, so that's the thing. When you have a normal data, okay, it is actually best suited if we use mean as our hypothesis testing and so on. If there are actually serious skew to the right or skew to the left, okay, so it means that we might have to consider using median as our measure of central tendency. Okay, the thing of measure of central tendency is we say on average. Okay, on average, what are the most people use as example here on average. Okay, what is the usage GB that the student use? That's the measure of central tendency. Okay, so in this particular discussion, I will show you a way on how we can assess the normality by using the graphical presentation and also the test, the normality test. Actually, why we need all of this? Okay, why we need all of this? Because sometimes one test only is not enough to decide whether our data is normal or not. Okay, even from our graphical presentation, sometimes we see that the data is skewed to the right. But when we perform another graphical presentation such as box plot, okay, density QQ plot, okay, t-test, the Kolmogorov-Smirnov test and Shafirov-Will test, it actually we say the result is contradict with each other. So how can we conclude whether our data is normal or not? That's why we need several normality testing to conclude whether our data following the normal distribution or not. Okay, so the rule of thumb, some practitioner, they say that if you choose three, if two say normal, one say not normal, so we can conclude that our data is normally distributed and so on. Okay, so that's just a general way on how you can checking the data normality, the shape of our data characteristic, right? So this is the way. Every graphical presentation, they have their own comment. Okay, but generally we will focus whether our data is symmetrical, skewed to the right or skewed to the left. Okay, so this is the thing that you need to comment when we have this kind of graphical presentation. Okay, so that's the thing. Right, so here we have Kolmogorov-Smirnov and Shapiro-Wilk test. This is actually the same test, but depending on situations such as the sample size and so on, it will best for us to pick one rather than both. Okay, so the thing here is actually uh, uh, quite heavily discussed among practitioners. Okay, even we have another normality test such as Darling test and so on, right? Okay, so at the end we will conclude whether our data is normal or not, suggesting okay the data normal or not, right? Okay, once we know that our data is normal, okay, we assume that we can use mean as to test the hypothesis testing. Okay, but in a way behind that we still have what we call it as theorem, which is what we call as theorem, central limit theorem. Okay, that's the thing that I will not discuss in this topic, right? So let's take a look at another discussion, which is hypothesis testing. Right, for this particular uh, topic, I only discuss one sample t-test. It is actually quite a lot more statistic that R can produce. And sometimes you might need another library or another package to perform the statistical test. Okay, but here that's why the topic itself it say basic. Okay, so here you can explore more if you need to perform any statistical analysis by using R. Okay, it is best for you to explore more. But the thing is, okay, the way that I want you guys to write when you answer this hypothesis testing is actually following this step. Alright, following this step. Okay, this is the discussion. Alright, so when we discuss about hypothesis testing in statistics, you must have two types of hypothesis, which is null hypothesis and alternative hypothesis. Alright, for this purpose, we will use the equal sign for all null hypotheses. Alright, for all null hypotheses, we say that the parameter is equals to parameter that we choose. Alright, and again, remember what we try to hypothesize is actually the population parameter. Right, that's why the symbol is actually mu. Okay, the population mean. Alright, so that's be very careful. And then alternative hypothesis will be divided into two, which are non-directional and directional. Right, so if we say that, okay, as example here is not equals to, this is actually okay non-directional. Okay, you don't mind whether the value is less than 15 or greater than 15. We only interested to know that whether our sample can infer that the population mean is different from 15 gibbs based on our sample information. Alright, so that's the thing. It means that the step 1 here, you need to have two hypotheses, right? Where the first hypothesis is always equal. Okay, and then the alternative hypothesis, it must be according to your question. So read the question carefully. Alright, and then the second step is to state the level of significance, whether the alpha is equal to 0.1, 0.05, and or 0.01. Pick one. Alright, or like this question, we already specify the alpha value 5%. It means that okay, when you change into the decimal value, this 0.05, 10% 0.1, 1% 0.01. Okay, what are the difference between what are the difference between if we specify this level of significance? It will affect on our confidence level specification here. If we use 5%, it means that for argument here, confidence level, you should use 0.95. If 10%, the confidence level here is 0.9, right? It's just the same as the alternative hypothesis here. Since that you use not equal, so the alternative should go two-sided. If greater, you use greater. If lesser, right? So that's the thing that you need to focus when you try to answer this question. Alright, and then step 3, find the p-value. Okay, the p-value is here, right? The output is saying that it is p-value. Okay, make sure that the data is correctly input. It means that now we want to test the usage GB. Okay, so the data here should be usage GB. Okay, and then make the decision. Okay, we reject H null if p-value less than alpha. Okay, so alpha here you have to specify it first, since that the question asks for 5% level of significance. So okay, if the p-value less than 0.05, we reject the null hypothesis. Reject means that we will not use this. We have enough evidence to say that the hash null is false. So we can conclude that at 5% significant level, the internet usage by the student is different from 15 gigs. Okay, right. So another thing that you can get from our output here is the confidence interval. Okay, confidence interval for how many percent? Okay, 95%. Okay, depending on how you specify the argument for confidence level, right? So that's the two things that you need to understand when writing the hypothesis testing. So how can you know the general function for t-test, right? Just simply ask R here. R will give you this description. Alright, the alternative, you choose either two-sided, less or greater. The mu here is the testing value. Okay, what are the value of population mean that you want to test? Alright, and the confidence level. Okay, it depends on the alpha value that we choose. Alright, so that's the thing that I need you to understand when studying this topic, right? Okay, I think that's all for this discussion. I hope you guys understand. Alright, and thank you for listening.